Alright, so in the last video we talked about SNAP and how if a molecule was symmetric, it was nonpolar, and how if it was asymmetric, it was polar. Alright, so if you don't remember that, go back and look at it. Practice drawing molecules and looking at if they're polar or nonpolar, or symmetric or asymmetric. Once we have that decided, we can start talking about how molecules will interact with each other. If I have two polar molecules, so let's say I have something like this. Alright, so I have CH3Cl here. Alright, my chlorine here is very much so more electronegative than anything else, so this is going to be delta minus. Okay, all of these things then are going to be delta plus. I'm probably better to write it over here, away from the other one, right? So what we see end up happening is that if I have a second one of these molecules, and usually I have billions of these molecules in a beaker or in the air or in a solid floating around, they are going to orient themselves so that the delta positive, the partial positive charge of one molecule can attract to the partial negative charge of the other molecule. Alright, and so we could also see another Cl down here going to carbon with my hydrogen. My other hydrogen's down here off the page, but you would see again here, because this is one of my delta pluses, right? All of my hydrogens are delta pluses. This is my delta minus. You would see that attraction here as well. Okay, and you just get a big network of these atoms that bind together and make these and keep the molecules together. That's if I have a polar molecule. Something like that will happen, and that type of an interaction is called a dipole-dipole interaction. Well, why is it called a dipole-dipole interaction? Remember back when you were in 3rd grade and you had magnets, and it looked a little bit like this, right? And then you had your north pole and your south pole on there, and well, now we're just going to change this to a plus and minus, but they're still poles, right? The opposite ends with opposite charges are poles, and since we have two of them, that becomes a dipole. Well, I have two molecules. Both of the molecules are dipoles, so it's a dipole-dipole interaction. What happens if it is not a dipole? What if it's something like CH4? Well, now there isn't a plus or a minus side to it. We have this big area where all the electrons are equally distributed. What happens with these guys is, let's say that a bolt of lightning strikes. I'm no good at drawing, so laugh away at my drawing of lightning here. There we go. Lightning is very, very negatively charged. So I have this lightning bolt that's very negatively charged. It comes next to my atom, or my molecule, with all this negative. All the electrons move away from that. So because of the lightning, or the outside source, something outside of the atom usually, or the molecule usually, we have electron movement to one side. Now that is not permanent. Just for a split second, my electrons move over here, so for just that split second, this becomes negative and this becomes positive, and it can attract to other molecules for a split second that way. This is called London dispersion. If you're in chemistry, it's called London dispersion. If you're in biology, it's called van der Waal. Van der Waals forces, okay? So depending on what class you're in, you might call it different things, but that's what it's talking about, where you have that temporary plus and minus, partial plus and partial minus, because the electrons are moved away from another charge. The last type of intermolecular force that we can talk about is the exact same thing as dipole-dipole. We've already discussed it. Everything is the exact same, but it is stronger because it has to do with NH, OH, or FH. If my molecule has any of those things in it, so water being the classic example of this, where I have an O bonded to an H, the attraction between the partially negative and the partially positive goes up a whole bunch. Okay, and because of that, we call this hydrogen bonding. So you have to look at your molecule. If it is dipole-dipole and it has an NH, an OH, or an FH bond in it, it is hydrogen bonding, not dipole-dipole anymore. Those are the three types of intermolecular attraction. And that is all we need to cover in this one. Hopefully that all makes sense.